All right, welcome everyone to IAM Best Practices. It's the afternoon. You're tired. We're gonna try to keep it fun today, talk about some permission stuff, some identity stuff. But since we all know I love policies, let's start with a fist pump for policies. There we go. We are the best session here. My name is Bridget. I am a senior manager. I own Access Analyzer, so we'll talk a little bit about that today. I've been in identity for a while, talking about permissions. You'll see my horse Pickles. And I'm joined here today with Matt.
Hey,
and
everyone.
we are going to cover a little bit of identity overview so you know what we're talking about. And then we'll dive into each of the best practices. So fun fact, we just launched revamped the new best practices. So you can go check them out. There are 14 of them. We're actually only going to cover 13 today. So you get to figure out which one we didn't cover. And we actually didn't cover it on purpose. But we'll dive into identity and credential management, permission management, and the tools to guide you. And for each one, we'll talk about why it's important, why you need to consider it for your business case, what it really means, and how to do it at the highest level. All right, when we talk about identity, it's always the same. Who can access what? And you can get super fine-grained in determining and setting those access controls. Who are your developers and your applications? These are your human users and your applications, your workloads, your automated jobs, whatever. Your what are your resources? These are your buckets, your Lambda functions, your batch jobs, your step functions, and on and on and on and on across AWS. And then where it all comes together, that's my favorite part. Those are your access controls. That's IAM. Those are your permissions. It connects the who and the what. And that's how we think about permissions. All right, so for the set of identity best practices, identity and credential best practices, I'm going to hand it over to Matt.
All right. Thanks, Bridget. Like Bridget mentioned, I'm going to walk you through each of the best practices, starting with identity and credentials management. We're going to explain why we think it's a best practice, and then we're also going to explain how to actually implement that practice on AWS. So hopefully you leave here with something to take back to your organization more than just Matt and Bridget said so. But please feel free to try that and let me know how it goes. So the first best practice I want to talk about today is require human users to use federation with an identity provider to access AWS using temporary credentials. Now I'm going to start with some definitions. So we've got human users, and human users are your developers, your business analysts, your data scientists. These are folks that are accessing AWS using the CLI, the console, maybe a client application. They're typically internal to your organization, and we refer to those users as workforce identities. They can be less often external to your organization as well. Then we have your workloads. Your workloads are your CI/CD pipelines, your applications, your infrastructure. These are the things that are authenticating to AWS where there's not actually a human behind the keyboard doing that authentication. And we refer to these as your machine identities. So why bother using an identity provider in the first place? And one reason is to centralize user stores. You've got your joiners, your movers, your leavers in your organization, and you don't want to have multiple disparate systems when somebody changes departments or leaves the organization that you have to go update. Reduce password fatigue. I know as a user, I don't want to have to be maintaining passwords in many separate systems. Users tend to pick less complex passwords, easier to remember passwords, and they also tend to duplicate passwords between systems. We want to decrease the number of systems that you have to secure. If you have a single identity provider, you can focus your efforts on securing that identity provider. And then ease of auditing. If you can tie back where the requests are coming from to a single source of identity, you make your life a whole lot easier from an auditing perspective. In AWS, human access is done with IAM Identity Center. And if you missed the announcement yesterday, AWS SSO is now known as IAM Identity Center. To get started with the IAM Identity Center, you're going to want to choose your identity source. Now you can choose Identity Center Directory, which is where you store your usernames and passwords directly in Identity Center. You can choose an existing Active Directory domain to connect to, or you can choose an external identity provider. If you choose an external identity provider, you're going to need to sync your identities with Identity Center. You can do that manually, or you can use the SCIM protocol to do that as well. And once you have those identities synced into Identity Center, you now have one place to manage permissions to your AWS accounts in your AWS organization. You can also manage connected applications with Identity Center as well. So now I'm going to jump into a quick Identity Center demo where we're going to walk through the console, we're going to add a user to a group, and we're going to assign some permissions. So let me go ahead and get that set up here.
Demo time, live demo. Matt's going to do it.
All right. So here we are in the Identity Center console. The first thing I want to point out is my favorites bar up here. Hopefully all of you have this on your favorites bar as well. So,
I mean, IAM is my favorite.
I'm going to go to the settings first and just show you my identity source that I have configured here. For the sake of this demo, we're going to use the Identity Center directory, meaning I'm storing usernames and passwords directly in Identity Center. But if I go over here, I can see that I can also specify an Active Directory or an external identity provider as well. I'm going to take a look at my groups. I've got a number of groups that correspond to the job roles that I have in my organization. And I also have a very lonely organization. It's just me. So what I'm going to do is I'm going to go ahead and I'm going to add myself to the developers group. I have a developer background. Seems like the appropriate group. Okay. Now you want to manage access in Identity Center with groups. You don't want to be assigning individual users to individual accounts. And I'm going to show you here in a second how you assign a group to an account. So you want to add your users to a group. Or like I said, if you're using an external identity provider, you can sync those users and groups from that identity provider. And then I'm going to go here to AWS accounts. I've got a few accounts. I've got my demo account and developer account. Let's say I want to give my developers access to both of these accounts. I'm going to click up here, assign users and groups. Like I said, you want to manage access at the group level. And I'm going to select developers. Just going to validate that I have selected the correct group here, and I'm going to click next. Now it's going to ask me to select my permission set. Now, what is a permission set? So let's go ahead and open this up. A permission set is a template. A permission set is a template for your IAM roles. So when I go and assign my developers access to an individual account, what's actually going to happen is Identity Center is going to look at this template, look at the policies that I have assigned in this template, and create an IAM role in my destination accounts that match this template. So you can see here, I've got a managed policy. This is a production environment. I might not trust my developers. I've got a read-only access policy here. So I'm saying that this permission set allows developers read-only access to the accounts that I assign it to. Let me go back to my wizard over here. I'm going to select developer access, click next, review what I've just configured here, and click submit. So this is where it's going to go into my accounts, associate that permission set with my accounts, and create roles in my accounts that I can then log into. So now that I've done that, what I want to do is just refresh this real quick. I'm going to log in as that account, or as that user. And I land on this page. So now I get a page where I can select either my demo account or my developer account, either account. I click to expand. And if I expand the other one, you'll see I have the same exact access to both accounts. I will click on Management Console here, and I'm into my account. And one important thing to note is I'm into the account, but I'm using an IAM role. So I'm using temporary credentials. I've used Identity Center to federate into my account. And now you can see up here, I've got this IAM role with this really long reserved name. All right. So let me just switch back.
There you go. Thanks for the demo, Matt. That was fun. Love live demos, and it all worked.
Yeah. So the next best practice I want to go to, we talked about human users, is require workloads to use temporary credentials with IAM roles to access AWS. Now, we just talked about temporary credentials, but I didn't really explain why temporary credentials are a good thing. So the first reason is they have a limited lifetime and an automatic expiration. So you don't need to rotate them, and you don't need to explicitly revoke them when they're no longer needed. Temporary credentials also eliminate the need for long-term credential distribution and storage. So with temporary credentials, applications just request them when they need them. So with that said, what we want you to do is prefer IAM roles or temporary credentials to IAM users or long-term credentials. Many of our AWS services have native integrations with IAM roles. We want you to use those native integrations. So here's an example. In this case, I'm trying to launch an EC2 instance. What I'm going to do is I'm going to start with Matt's IAM role. I'm going to add it to what's called an EC2 instance profile, which is mostly just a container for my IAM roles. I'm going to take that and associate it with an EC2 instance. Once that instance profile is associated with that EC2 instance, what my applications that are running on that instance can do is they can automatically request those temporary credentials. Those temporary credentials are automatically refreshed and rotated for me. And if you're using our CLI or our SDK, they're automatically discoverable as well when you're running on that instance. So a pro tip as well, when you're dealing with IAM roles, use a single role for a single responsibility. Use a different role for different applications. Use a different role for different services. Bridget is going to talk later about least privilege. This is a very important concept when we talk about least privilege. So what do we do for those workloads that aren't running on AWS? And now you might have workloads that are running in a data center. You might have workloads that are running on other infrastructure. So instead of creating and distributing and maintaining those long-term credentials, you can use IAM roles anywhere. And this is a fairly recent launch. So what IAM roles anywhere does is it uses X509 certificates from your certificate authority to authenticate with AWS and provide secure access to your AWS resources. So if you have workloads running outside of AWS, check out IAM roles anywhere. Next best practice, require multi-factor authentication, or MFA. Now, most of you probably know what MFA is already, but MFA combines what you have or what you know, which is typically a username and password, with what you have, which is typically some sort of token. We want you to apply MFA to all humans accessing AWS resources, and that includes your IAM users, if you do still have them, your IAM root user especially, and any other human that's using your identity providers to log into AWS. All right, next best practice is rotate your access keys regularly for those use cases that do require long-term credentials. Access keys are a particular type of long-term credentials associated with both IAM users and IAM root users, and they're used for programmatic access to AWS. We don't recommend creating access keys for your IAM root user, but for IAM users, you should rotate your access keys. Now, the water wheel that you see here is going through tens of rotations per minute. That's probably a bit extreme for how often you should rotate your access keys. And typically what we mean by regularly is it's defined by your security and your regulatory requirements.
I was hoping people were actually looking at those pictures.
So why rotate your access keys? We want to make those long-term credentials a little less long-term. So let's limit the length of time that the access key is actually valid. But equally, if not more important, is to practice for when you actually need to revoke those access keys, say when an employee leaves the company. How do we rotate access keys? First thing we'll do is we'll start by creating a new access key. And now we have 2 access keys for our IAM user. We'll update all of our applications that are using those access keys to use the new access key. Step 3 is we'll validate all of those applications are updated. Now, this one tends to be use case specific. You might have an out-of-band way to validate that your applications have been updated and are using those access keys. You can also look at the old access key, and in the AWS console, there is a last used property where you can determine when that old access key was last used. You can also do the same lookup with the CLI or SDK as well. So once you've validated that your applications are updated, you'll mark that old access key as inactive. And marking an access key as inactive just renders it unusable. You can always go back and mark it active again if you find that there is still some use cases that are using that old access key. And then you'll wait some period of time, whether that's days or weeks, that's kind of up to you. You'll wait some period of time and then you'll delete that old access key when you're sure that it's no longer in use. And you can kind of tighten some of these windows as you get more experience and trust your process a bit more. So once you become very confident in your access key rotation process, maybe you wait hours instead of days to actually delete the old access key. Now, this is one of those best practices that I hope you actually don't have to use. And I say that meaning we want you to use temporary credentials. We want you to use IAM roles. We don't want you to have to go through this access key rotation process. We want you to take advantage of the fact that IAM roles their credentials are rotated for you. All right, and the next one is a big one. Safeguard your root user credentials and don't use them for everyday tasks. You don't want your environment to end up looking like this tree over here, where your root usage is the foundation of everything that happens in your environment.
That was a good one.
So why do we care to limit the use of our root credentials in the first place? Well, first of all, they're long-term credentials. And I just got done talking about how we want to prefer temporary credentials to long-term credentials. The second reason is they have full unrestricted access to your AWS account. Now, roles created underneath that root user can be restricted by IAM, whether they're a resource-based policy or an identity policy, and Bridget is going to get into a little bit of that. So for these reasons, we want you to limit the use of your root credentials. Now, there are some actions in AWS that still require the use of root credentials, but those are things like updating the email address that's associated with the account, changing the support plan on the account. These are actions that you're not performing frequently, so you really should not be using your root credentials on a day-to-day basis. Now, how do we protect our root credentials? First thing, we need to protect the credentials themselves. Now, when we talk about credentials for both IAM users and IAM root users, we're talking about two different types of credentials, maybe three different types of credentials. There's the console username and password that you use to log into the AWS console. There are the access keys that we talked about before, which are used for programmatic access to AWS. And then there's MFA tokens as well. So the easiest credential to protect is the one that doesn't exist. Don't create access keys for your IAM root user, and you don't have to worry about protecting them. For the console login, we suggest that you create a complex password and store it in something like a password vault. For the MFA tokens themselves that you're going to attach to the root user because you saw my previous slide, for the MFA tokens themselves, if you have a physical token, you can store it in a physical safe and control access to that safe. If you have a virtual token, you can take the secret key that's used to generate the time-based one-time password and store that in something like a password vault as well. Consider using something like a two-person role for access to the MFA token as well as the password. And what I mean by that is no single person should have access to both. And that does depend on your particular organization's requirements, but that's a general good practice. The other thing you can do is you can just take that login password and just throw it away. Set a very complex password for it, and just don't write it down anywhere. Because then you'll rely on the root credential recovery flow process for that password, which you have to protect anyway. So that brings us to the next thing, protecting the root credential recovery flow. Now we can reset either the password itself or the MFA token. Those are the two things we need to protect here. Resetting the password is done via email to the mailbox associated with the account. Resetting the MFA token is done via a combination of email and a phone call. So you'll want to control access to the email address associated with the account, as well as the phone number associated with that MFA token. And again, consider using that two-person role. Now, once your credentials are protected, you want to prevent and monitor the usage of them. I said prior that the root credentials had unrestricted access to your account. The one thing that you can do is you can create what's called a service control policy, which is an AWS organizations construct that can deny root in child accounts in an organization. So you can use IAM to block root in child accounts if you're in an organization. Now, on the monitoring side, we recommend using a service like AWS Guard Duty to look for unauthorized uses of those root credentials. And with that, I am going to pass it over to Bridget to talk about one of my favorite topics as well, which is permissions management. When Bridget and I were trying to figure out who was actually going to talk about what in this topic, or in this talk, we flipped a coin, and you can see who won that coin flip. Also, I don't have a really cool horse.
Yeah. Permissions and pickles go together. So I'm going to take it from here to talk about best practices for permissions. So the first, we need to talk about permissions and what they are. When we think about permissions, there's two parts. One is your job. Who's written an IAM policy? Raise your hand. Only one person? Okay, there we go. This is where you get to specify who can access what, and you get really fine-grained. You can specify the principles, the actions, there's thousands of them, the resources, there's hundreds of types, and you get into the conditions for specifying who can access what. Once you specify that, then it's our job, and our job is to enforce. So for every access control in AWS, we look at the policies, we look at the requests coming in, and we give a yes or no answer, an allowed or denied. This is a policy. I'm sure you all have seen it, hopefully. We like to call this the PARC model. And essentially you can say allow, principal, which action they can have, on which resource, under which conditions. You can use a lot of documentation and tools we have to actually specify these items. So when we think about the first best practice, you think about applying least privilege. And I want you to think about applying it just like you would apply makeup. Just kidding, that's not really doable, but I thought the picture was funny. So what is least privilege? Least privilege is granting users and systems the narrowest set of permissions to complete the required task. And we hear least privilege all over this conference at Reinforce. We hear it from customers, but I need you all to know that that required task will change based on your use case. You might be in development, you might be exploring, building something new. Your permissions are gonna be broader in that scenario versus if you're in production and you have a hardened workload that deals with processing credit card data, those better be very tight in permissions. And so there is this balance that you wanna work towards to let builders build, to let the business innovate, also set them up for success so you can prevent dangerous actions, have an accountable security posture. So when you think about least privilege, it's not a checkbox, it is a journey. And the journey, you can be anywhere on this, and different workloads, different teams are also on this. So if you're just getting started and you're exploring, you can start with AWS managed policies or custom templates. A lot of organizations come out with things they approve of. Then you don't want to stay there. You're gonna want to get to right sizing, and that's where you can generate and customize policies with IAM Access Analyzer. But if you really want to get fine-grained, and you know that's how I like to operate, then you're gonna want to do the DIY model, the do-it-yourself model. And that's where you get to specify conditions. But don't worry, we have your back there too, because we have policy validation with IAM Access Analyzer. And we're gonna demo 2 of these today. But before you get doing that fine-grained permission within the account, you need to establish permission guardrails across multiple accounts. So hopefully you're using multiple accounts for your workloads and you're using them with AWS organizations. And then you're gonna wanna establish those permission guardrails. This sets engineering teams up for success. It kind of gives them those bumpers so they do the right thing. You would wanna restrict who can modify network controls, who can modify powerful permissions, who can grant access to modify permissions on a bucket, etc. So think about what are the general things you wanna restrict and bubble them up to the guardrail across your entire organization. And one of these guardrails is a data perimeter. We've heard this more and more from customers. We're working on helping you take all of the access controls that we have across AWS and put them together so you can establish a data perimeter. And this will help you meet your compliance requirements, build a corporate boundary so your stuff stays within your stuff, allow developers to build within a safe place, and have defense in depth. So what is a data perimeter? It is a set of preventative guardrails in your AWS environment that helps you ensure your trusted identities are accessing your resources from your expected networks. So if we think about this picture, you want to protect everything that's in your space, and that's that green box over there. Pickles, he's out on the internet. You might not want him in your AWS environment. You don't know what he's going to do. And so what makes a data perimeter? I talked about your trusted identities. Those are your users, your roles within your organizations or AWS services operating on your behalf. Your trusted resources, that's your stuff. Those are your buckets, your Lambda functions, your queues, your topics, all of the good things that AWS has to offer. And then your expected networks. These are your on-prem data centers or your VPCs or networks that AWS is using to act on your behalf as well. We have a lot of those management services where we act on your behalf. If you want to, we recommend using conditions to restrict access further. And there are a lot of condition keys out there, and we keep adding more. Let me tell you, then Matt's going to tell you his favorite condition key, but we'll talk about first. So when we talk about conditions, think about the term, but only if, right? So you want to grant access to these actions, but only if these conditions are met. You can create Lambda functions, but only if you're using CloudFormation. You can write data, but only if that resource is in your organization. So if you want to grant access or restrict access and you have like this but only if feeling, go look for a condition key. How do conditions work? There are 3 parts to it. One is the operator, the next is the key, and the next is the value. The only part that you get to specify something unique to your organization is the value. The operator is string equals, string like. You don't get to make up your own operator. They're there in the IAM policy language. The key is also something we define because that's what we put in the context to evaluate against your policies. So you can, the key could be principal is AWS service, resource tag. There's a lot out there via AWS service, principal ARN. The list goes on. And then you specify the value that is there. Maybe you want the tag to be pickles because you're working on pickles project. So Matt, what is your favorite condition key?
So I think it has to be what we call one of the global condition keys. Global condition keys means they're available for all AWS services. And since we just talked about data perimeters as well, it's applicable to data perimeters. So I'm going to cheat because there's really 2 condition keys that are my favorite. Principal org ID, AWS : principal org ID, and AWS : resource org ID, the combination of the 2. So what those say effectively is that this resource is accessible, but only if the principal is within my organization. And conversely, for resource org ID, this resource is accessible, but only if the resource is within my organization. So the combination of the 2 is kind of the foundation of data perimeters.
Awesome. And I would say my favorite condition key have to do with the management of services. A lot of customers are using services that perform actions on your behalf, Access Analyzer being one of them. And so you might want to say, hey, I'm granting access to this specific action, but only through an AWS service. So that's the condition key via AWS service. Or I'm granting this access if it is an AWS service acting on your behalf. Okay, so we talked about all the ways that you can control access and the best practices for applying least privilege, using conditions to do that. But what are the tools out there that can help guide you towards these best practices? And the way we think about least privilege is it doesn't happen overnight. It is a journey. And 3 steps to that journey. You're going to set permissions, verify permissions, and refine them further. And as you get more comfortable, as you know what you're building, as you make it to production, this loop is going to get tighter and tighter. But notice that the data perimeter is on the outside and allows you to go through this journey as you innovate and as you build. So get started with AWS managed policies and move towards least privilege. AWS managed policies are general to all AWS customers. They are not going to be specific to your use case. So you can start there to explore, but you need to move on. And so when would you use AWS managed policies? Well, if you're getting started, Maybe you're just poking around. You might want to use power user access. If you're exploring a new service, maybe you want to do a read-write. If you're like, hey, does Secrets Manager meet my use case? Go play around with it in a development environment. Human users who need general access, so maybe a network administrator, a security admin, and then service-linked roles. And these are the roles that AWS services use to act on your behalf, and each one of them will have a policy that they need. So Access Analyzer does a lot of acting on your behalf, and there's an Access Analyzer service role policy that grants AWS the permission to do that. Then you want to use IAM Access Analyzer to generate least privilege policies based on access activity. So this is a feature, we launched it in 2021. So if you haven't checked it out, I'd recommend going and checking it out. And here's how it works. You run your application, you run your task. My team recently used it by running a run book that they needed to perform some steps. And then they were creating a fine-grained role for that operation. And they went to Access Analyzer and they said, hey, Access Analyzer, will you give me a policy? Access Analyzer went to work, analyzed the CloudTrail logs, and then generated a policy. And when we generate this policy, you can customize it further. You can add additional actions, you can specify resources. We actually give you the template to do that, and you can add conditions along the way. So we are actually going to demo it. Pickles the unicorn has decided that he wants a policy, but it's really Matt. And so Matt is gonna do it live demo, so hopefully it works. There's gonna be a little bit of a break because we're gonna wait for the policy, so maybe I'll try to tell a joke. I don't know. You wanna go for it, Matt?
Yeah, Pickles the unicorn sounds a lot more exciting than me. So what we're looking at here is just a Lambda function. Don't worry too much about, I'm not gonna make you read my code. Effectively, we're making a couple AWS calls, and I'm just gonna go ahead and run it. You can see here that it's looking at some instances, getting some details about them. It's looking at some secrets. It's skipping over the Bridget secret, looking at the Matt secrets. So what I want to do is I want to then go to my IAM role that I have associated, my execution role that I have associated with my Lambda function. We talked about native integration with IAM roles earlier. I'm going to click on, let's give it a second. I'm going to go to the one I already have open. And I'm going to scroll to the bottom. At the bottom, you'll see generate policy. You can see I have actually generated a policy for this IAM role before. I'm going to go ahead and click generate policy. All right, I'm going to choose just over the last day, just so it doesn't take more than the minute that we said we were going to have to wait. I'm going to select my CloudTrail trail because what it's actually going to do is it's going to go look in CloudTrail at the actions that this role has performed and generate a policy based on those actions. And I'm also going to just select US East 1 for the sake of this demo. I'll use what's called a service role. I'll just select the existing one here and I'll click generate policy. So while this is generating, what I want to do is quickly show you the policies that I have attached there now. As a developer, I just went in there and said, hey, I need to perform all EC2 actions and all Secrets Manager actions. Yeah, that should be good enough.
That is not least privilege.
No. And then I've got even this basic execution role. And this is one of those managed policies that I attach to my Lambda function so it can do things that Lambda functions need to do, like logging. So what it's doing now is it's going ahead and looking at my CloudTrail trail, looking at the calls that I made, and saying, how can I build a policy from those CloudTrail calls?
One thing we have gotten a lot of customers asking us is, how does this happen? We actually do go look at your CloudTrail. We identify the event and we map it to the appropriate IAM permission. And so that is something that Access Analyzer is doing on your behalf. And then we also put it in a policy and make sure that it complies with the IAM policy language and the specifications there. And so that is another thing we're doing on your behalf. And so this will help you get closer to a least privilege policy. And what we're seeing is a lot of folks play around in development and then run this so they at least get the actions and have a good framework for generating that policy.
So what are the other use cases that I've seen used here is, let's say infrastructure as code or CloudFormation templates. You want to see, hey, what access does this infrastructure as code need when I deploy it? So you set a broader policy first, deploy your CloudFormation template, and then go back and generate a policy based on that CloudFormation template. So you can get the exact permissions that you needed to deploy that CloudFormation template.
Is it still going, or do we have to refresh?
It's still going. No, it'll stop you when it's done.
How many folks have used IAM policy generation? Oh, not very many. All right, we got like 1, 2, or 3. So we are continuing to add. We generate action level permissions. I don't actually know the real number top of my head, but I think it's 60-ish services, and we are continuing to add more and more. So make sure you keep a lookout that we will continue to add some. Oh,
there
we
we
got
go.
a success. Live demo fun.
All right. All right, so it went through CloudTrail. It detected that, hey, Matt, you're using CloudTrail, some CloudWatch logs API calls. You're using some EC2 API calls, and you're using some Secrets Manager API calls. If I wanted, I could add additional actions here, but for the sake of this, I'm just going to go ahead and click Next. And it takes me to this template. So for some API actions or some actions, it's able to tell me that, okay, this applies to all resources. Certain actions in IAM do apply to all resources. Certain actions in IAM let you specify the specific resource that you're dealing with. Now, when there is a resource in question, like in the case of creating a log group, it's going to give me this template that I can then go back and modify. So what I'm going to do, I'm going to go ahead and fill in some of these values. I'm going to just go ahead and grab the account ID from up here. And for this, I want to do AWS Lambda super cool.
Super secret. Super cool.
I really shouldn't name these things so long for a live demo.
I always just name them Pickles. You got to get yourself a horse.
I guess I need a horse.
Yeah, then it will work out.
Okay, and then I'm going to substitute the account ID there. And what I want to do is I want to say only Matt secrets, not Bridget's secrets.
Not my secret.
So then once I have that all straightened out, we're going to talk about policy validation in a second, but you're going to see that I don't have any warnings or errors there. I'm going to go ahead and click Next. And I'm going to name this fine-grained.
Fine-grainer? It is more fine-grained. There you go.
And I'm going to click Create, and it will automatically create and attach that policy to my role. Now, I still have these other policies attached to my role, so I'm going to go ahead and delete them.
So this is really the act of fine-tuning permissions right now, refining all of what you don't need anymore.
And it's going to make me, okay.
We'll do questions after.
Now with my fine-grained policy, I'm going to go back to my auditing function. I'm going to go ahead and run it again. There we go.
And it should work. There you go.
It still worked.
And now your Lambda function has fine-grained permissions. Thanks, Matt, for the demo. We'll go back to the slides. Pickles is very impressed with your demo. All right, and one other thing we did talk about was policy validation. And you can also use IAM Access Analyzer to validate your policies. And when we talk about policy validation, we have your back. We have over 100 checks that are making sure your policies are secure and functional. And we have 4 ways to do that. We show you checks on security, on errors in your policies, general warnings, and suggestions. Each check has an actionable recommendation that goes to documentation to give you even more information. It shows you where it is in the policy. You can do this while you're authoring policies. You can also do this for your existing policies. And so we have customers that are putting policy validation in their CI/CD pipelines, and they're really looking at those security checks that are coming up and the errors that are coming up. Those are the ones that you would want to automate as you deploy policies as infrastructure as code. We're going to do another live demo. Matt's going to show policy validation in action. My favorite policy validation check is IAM Password Star, so maybe you can show that, but I don't know if you're going to do that.
We can show that.
Oh, look at that right there.
There you go. So I am in the Create a Policy console here, and you can see that I do not know how to spell. So if I look at the bottom, I can see my errors and warnings. I click on the errors, and it tells me that you have an invalid action. Now this one's fairly obvious, but there's oftentimes that you forget an S at the end of an action. You should do run instance instead of run instances, something like that. So what I'm going to do is I'm going to go ahead and fix the name of that action, and you can see that error disappears. But now I've got new errors. So let me first take a look at the warnings. And you can see that the findings have classifications here, so I can focus my effort on errors, which means that my policy is just non-functional. But I'm also going to take a look at this warning, which says I have a missing version in my policy. So I'm going to go ahead and add that. Side note, you generally always want to use the latest version, policy version, so that you can take advantage of things like policy variables in this specific case. But now I'm still left with one security warning. And this is where, like Bridget was saying, IAM Access Analyzer has your back. So here it's saying you have past role with star in a resource, and it's also telling me why that's a bad thing. And for those that don't know what this means, is this means that I can provide any IAM role to an AWS service. So even if it has administrative access. And that's generally not something that you want to do. So what I'm going to do is, it even tells me how to fix it here. I'm going to take its advice.
You're going to take Access Analyzer's advice?
And we'll see if that's a good idea. So I'm going to say, yeah, you can only pass Matt's role. And now the error goes away. The other thing it told me to do, just as an aside, is you can add a condition key that says I can only pass Matt's role to a specific service. So if you're dealing with pass role, adding that a little bit of extra safety is usually a good idea.
The other thing about policy validation is we are continuously adding new checks. So if you have an idea, you can tweet us at AWS Identity or tweet me or somehow get a hold of us, and we will consider it for our next launch of checks. Okay, so the next best practice is verifying public and cross-account access. When it talks about that data perimeter, anything that grants external access beyond your zone of trust, you want to verify it. And you can do that with Access Analyzer. So let's imagine we have a production account for Pickles because he has his own account with some hay and some treats. He has a bucket of carrots, a roll, and all of these grant external access. So Pickles data processing account, totally okay. An account from an unapproved third-party partner, not okay. I don't want anyone messing with Pickles unless I know who they are. Central security account to make sure everything is meeting the standards of the organization, perfectly okay. Developer account, no, Pickles is a production one. And so how does this work? You enable Access Analyzer for your account or your organization. It is free. We continuously monitor and review access controls on those resources. We have 7 resource types, and we're constantly adding more. We use automated reasoning to determine public or cross-account access, so we know with certainty if there's a path to public. We generate findings for you to review, and then you get to go do the verify. You can say, oh, yep, I agree that that data processing account is allowed access to the production Pickles, or you can say, hey, that third party, not allowed, and you can go update your policy. And talking about continuously monitoring and reviewing, you want to review your users' roles, permissions, policies, credentials, and see if they're used. And if they are not used, get rid of them. They do not bring you joy. They will not make you happy. And if you remove them, you help with your security posture. So where can you do this and how can you do this? Well, you can look at roles and IAM users. We have last access information. You can see when they were last used. For each role, you can go into the permissions that are granted and look at the services that they have access to and which ones were used or not. And then for some actions, we tell you which ones are accessed and which ones were not. And we will be adding more of those along the way. And if you are using organizations and that SCP that Matt talked about, that's a service control policy, you can go to your organization, you can see all the services that your organization use, and maybe restrict access to the ones that you're not. So if you've decided not to use a service, it's not valuable for your business use case, you can just restrict it and you don't have to worry about it ever again. You restrict it for your entire org. So use that last access information to help you know what's okay to remove and help improve your security posture. All right, and the last slide we have here is just what to take back, right? If you take 4 things back with you to your organization, you want to confirm that you're using temporary credentials for human access and for workload access. You should start to cringe a little if you see long-term keys and really inspect and challenge the use of long-term credentials. And if you have long-term credentials, then you better be rotating them. You better have MFA on them if they're for human access. Then you want to think about establishing those guardrails to help those teams build and innovate, and think about it at the org level, the organizational unit level, the account level. And then finally, you want to go into those accounts, right-size those permissions, verify, and really get them to a fine-grained permission model for your workloads and your human users. Thank you so much for staying with us this afternoon. I hope you all had fun at Reinforce. Hopefully you can take a look at those best practices and start chipping away at them as you go back to your organizations. Don't forget to take the survey, and thank you, Matt.
Thank you.